Considering that we live in a star system with one star, the Sun, most people don't even consider whether there could be systems with a number of stars other than one. Fortunately, astronomers are not the majority, and they've been studying this question since the 17th century, and it's quite complex. The whole point is that sometimes it's hard to tell if these are two stars that are close together, or if it just looks that way to us from Earth, and in fact there are light years between them. Then such systems are called optically dual. Also, such systems often have a dominant star and a companion star that is much smaller than the dominant star. These small stars are difficult to spot in the shadow of their companion, and such a system can be mistaken for a single star. The next problem has to do with statistics. If we want to understand how many single star systems there are, it is unclear whether our sample can be extrapolated to the entire galaxy. Let's say we have studied 50 nearby star systems, and 25 of them are single star systems. Does that mean that half the stars in our galaxy are loners? No, not likely. At least in the Milky Way arms this number is likely lower. But again, we can't say for sure. Therefore, it is still not completely clear what star systems our galaxy consists of as a percentage. Some researchers believe that there are about 70% of star systems with a single star, and some say that there are less than half of them. Two star systems are also unclear as to how many, but quite a few, ranging from 20 to 50%. By the way, interesting fact, on the internet, you sometimes see planets in double star systems referred to as Tatooine-like. Because of the fact that Tatooine, home of the Skywalkers and Star Wars, had just 2 stars. Well, what about the remaining interest? The remainder of the star systems are star systems with 3 or more stars. Such systems are called multiple systems. This is where my brain personally broke down when I tried to imagine a system with 3 stars orbiting around a common center of mass. So what's the bacchanal going on in a system with 4 and with 5? Yes, they do. By the way, if the system has more than 10 stars, it is considered to be a star cluster. Well, today we're going to try to get a handle on what a 6-star system in the constellation Gemini called Castor looks like and works like. Stellar systems of such large multiplicity are rarely encountered by scientists. 70% of multiple systems are star systems with 3 stars. Castor is also somewhat of a multiple star system with 3 elements. Except that each of them is split into 2 more separate ones. That is, Castor is a star system with 3 pairs of double stars. Sounds crazy, doesn't it? Castor is the second brightest object in the constellation Gemini and is observed as a single star point to the naked eye. This constellation is not hard to find in the night sky. To do this, simply find the dipper of the Big Dipper and draw a mental straight line through it to the east. The 2 brightest stars in this constellation are Pollux and Castor. Castor is only the second brightest in this constellation. He's 23rd in the entire firmament. And it's 51 light-years away. Castor's system is fairly young. Scientists estimate it's only 200 million years old. No comparison to our Sun, which is 4.6 billion years old. Castor was discovered back in the 17th century and immediately noticed that something was wrong with it. Even in pre-flood telescopes, 2 dots were visible, and for a long time Castor was considered a double system. But it turned out to be much more complicated than that. Each of Castor's 6 elements has a very intricate system of rotation around a common center of mass. But let's start by breaking down each of the stars in the system individually. The largest brightest star in Castor is Castor A. It is only 2.59 times heavier than our Sun, but has 30 times the luminosity. Because the temperature at the surface of the luminary is about 9,000 Kelvin. The second largest facility in the system is Castor PA. It has a mass of 2.2 solar, meaning it's quite a bit Castor A, but has a luminosity almost half that, it's 14 solar. This star is also a bit cooler and has a temperature of 8,200 Kelvin. It is orbiting Castor A, and both of these objects make one revolution around each other in 350 years. Admittedly, it all looks very strange, and it's clearly not what you expect to see when you hear the word turnover. Well, the third and smallest pair in this system, Castor Sa, is the dominant star there. It has a mass of 0.62 solar masses. Castor Ca has a temperature of 3820 Kelvin and a luminosity 10 times less than the Sun. It also revolves around Castor A, but already in a very highly elongated orbit, so that one revolution takes 14,000 years. At the same time, this object is distant from the other two by 1,000 astronomical units. I will remind you that an astronomical unit is the average distance between the Sun and the Earth. Each of these stars is a double luminary, and therefore has another companion. So, Castor AA has a companion, Castor AB, which is half the size of our Sun, and it makes a revolution around A in a little over 9 Earth days. Castor BA has Castor BB, which is also half the size of our Sun and orbits its host star with a period of 3 Earth days. And even little Castor SA has a companion Castor SB, which, you won't believe it, is also almost half the size of our Sun. Okay, he's a little bigger, his mass is 0.57. So the third pair is pretty equal in terms of mass. This pair completes a complete revolution around a common center of mass in less than 20 hours. All of these pairs orbit around a common center of mass in a very bizarre orbit. And since to the naked eye this system looks like a single system, their luminosity to us adds up and reaches 57 solar. All stars except Castor A and BA are red dwarfs, while the two largest stars in this system are white stars. The A and BA Castor will remain in the main sequence stage for several 100 million more years. Recall that main sequence stars are those that are in the main phase of their evolution. All stars go through this phase, some longer, others faster. In the life of each star, such a period is the longest in time. Red and yellow dwarfs can be in this stage for billions of years. So after the death of Castor A and BA, the other stars in this system will still continue to exist. Scientists are actively looking for exoplanets in this system, but so far, either because of the small age of this system, or because of the complexity of its study, has not managed to find any. Like I said, all of these Earth objects look like a single star, and for the most part, scientists get their information with a spectrometer. This means that astronomers watch the changing luminosity of star points and realize that they are already seeing another object in front of them when one star overlaps with another and begins to glow a different color. Again, because of the close proximity of the stars to each other, it is difficult to understand how this system came to be in the first place. But there are a couple theories. First, it could be due to the fission of a single star under gravitational influence. It is also possible that stars were captured from other star systems. But the basic theory is that multiple systems, including Castor, form from a single proto-black like all other stars. It was just split into several parts, so there was not one big star, but several smaller stars. But the miracles don't end there. The scientists noticed that 15 other stellar objects are also gravitationally linked to the 6-star Castor system. Among these objects, there are both large and small stars. These stars share a common motion and also have roughly the same age. Scientists have dubbed this group of stars the moving Castor group. But the fact of this group's existence remains in question for the time being. Thank you for watching the video to the end. I'd love to hear your suggestions and feedback on the content in the comments. I'll see you in the next clip.